We are really emphasizing graphing calculator approach for all this. Because any of these calculations, we can do them by hand, just like we've been doing with our others, but ultimately technology is our friend, so we are going to use that to work with our information. We are going to now talk about two means, so two different groups where we have dependent samples. So we have our same requirements, but basically if we're talking about a mean, the requirement is either it has to be normal or n is greater than 30. Okay, those are the criteria that I expect you to verify every time. The second one that we need to look at for this specific testing scenario, we have to have dependent data. Dependent, they depend on each other, they are connected in some way. So I can't just take two random sets of data and do this test. These are sets that are connected. So, with these, we have to look at a null alternative hypothesis, same as we have been doing. But what we're going to be doing, since these sets are related, is we're going to be looking at the mean of the difference. So maybe it's, I gave you a pre-test and a post-test for a chapter. Okay, so that data would be dependent because I'm not going to compare Selby's pre-test to Grady's post-test. That wouldn't make sense, right? I'm going to compare Selby's pre-test to Selby's post-test, Mara's pre-test to Mara's post-test. So the data depends on each other. They are paired up. And my null is that there is no difference, that you are the same. So the mean of the difference is 0. Then the alternative could be not equal, less than, or greater than. Then, just like before, we have our alpha. We can do classical or p-value approach, but we are going to stick with the calculator, which is p-value approach. So remember with that, big thing, if p is less than alpha, you reject. P is your probability. So if your probability is smaller than alpha, that means it's very unusual. That's when you reject. If p is bigger than alpha, we fail to reject. So let's look at a scenario. The following data represent the cost of a one-night stay in Hampton Inn Hotels and La Quinta Inn Hotels for a random sample of 10 cities. Test the claim that Hampton Inn Hotels are priced differently than La Quinta Hotels at the alpha equals 0.05 level of significance. Assume the data is normal. So my criteria is met because I already told you it was normal. The null hypothesis would be what? It's just always the same. There is no difference, so the mean of the difference is 0. The alternative. I want to know if Hampton is priced differently. So what does that mean? Not equal to 0. Okay, so the process for this. We are going to enter this data in L1 and L2. These are, think of them as ordered pairs because it's one city and two hotels within that city. So order matters. Make sure you don't delete your lists, just clear them. So we're going to go to Stat, Edit, clear out anything that's there. And we'll enter this in L1 and L2. Okay, but what we care about is the difference. So I want you guys to go up onto L3. I want you to highlight L3. And then it says L3 equals blank. We want the difference in these prices. So we are going to do L1 minus L2. You can go through and calculate that for every single one of them, but our calculator will do it for us. So while I'm on L3, I'm going to hit second number 1. So it says L1 minus second 2. So list 1 minus list 2. And hit enter. That gives us the difference. Now, it's everything we've done before, except we're running it off list 3, the difference. So if you want to make some notes on what we did. We entered the data in L1, L2, and L3 is L1 minus L2. So that's our first step. Second step is anytime we're doing a test for the mean, that's what we are doing on the last assignment. So stat test number 2. The t-test. All right, do we want data or stats?
Data.
Data, because we just entered everything there, so highlight data. Okay, the mean of the null is 0, that's what we want. But the list, make sure that probably says L1 right now. It needs to say L3. So if you hit second, number 3, you can change the list to L3. Frequency should be at 1. We are testing not equal. So, with 0. List was L3. So then our result, T is 5.2716. Our P, be careful, watch. Sometimes it has scientific notation. E -4 means you move the decimal back 4 places. So what would my conclusion be? Alpha was 0.05. If I ask you to write a sentence explaining what it means, there is sufficient evidence. The hotels are priced differently. So, everything we're doing today, it's really what we've already done, the t-test or the t-interval, but you have to make sure you set it up to be for the difference, not either of the original sets. All right. Questions on that one? Our confidence interval, we can do as well. We've done those confidence intervals. I'm not going to ask you to do them by hand. We're just strictly going to use it on the calculator. So if I ask you to construct a 90% confidence interval for the mean difference in the price of Hampton Inn versus La Quinta hotel rooms. So we already have it all entered. We already have our null and our alternative from the previous example. So this one we go to stat tests number 8, the t interval. Okay, again, it's based off data. Your list should be L3. My confidence interval, confidence level should be 90%. So what this means is we are 90% confident the price difference is between $33 and $69. Is my null hypothesis in that interval? My null was no difference, so since 0 is not in the interval. Reject the null hypothesis. So you can reject it from the confidence interval or the t-test. Okay, But the key to all of this, it has to be paired data. Can't just be two random sets of data. They have to have the same number of points. So if I had a pre-test for Anna but not a post-test, I couldn't include her. Okay, you have to have the X and the Y for both of them. Questions? I really want to. I'll go ahead and look at, I might put up another example here in a minute, but I want you guys to try some first and see if we're having any trouble. So this is showing data where an SUV smashed into a car in an accident. So it's matched pairs because it was from the same accident, the damage to each vehicle. So does the data suggest repair costs are higher for the car? What would my null hypothesis be? Right, it's always that there is no difference. So the mean of the difference is 0. The alternative, it's either the mean of the difference is not equal, greater than 0, or less than 0. If the car is higher, we always do L1 minus L2. If the car is higher, would you get something greater than 0 or less than 0? Less than. So my alternative would be the difference is less than 0. Does that make sense? Do you want me to walk through setting this one up and doing the test on the calculator? Okay. If you don't care, you can go back and start working on your homework. If you would like to run through this one, then I'll go through it with you. So you're going to enter your data in L1 and L2. If mine will ever open here. And make sure you clear out all 3 lists that you have.
Is this one on our sheet?
It might be. Is it?
I didn't know if you were like
Oh,
through one.
I just took one out of the textbook so I could talk about an alternative hypothesis there. It's possible I picked one off the homework, I don't know. Okay, and so once you have that entered, what do you do for L3? L1 minus L2. Okay. So then we go to stat, tests, number 2. It's based off data. To be based off stats, I just have to give you the mean and the standard deviation in the problem.
MU thing,
The mean,
we have to say that's 0.
yes, it should be 0 on all these. The list should be L3. This time I'm testing less than 0. So if we calculate it. So then what I would expect you to write down would be your T and your P. So the T is -2.6855, the P 0.0181. I didn't give you the alpha level. Let's say alpha was 0.05. So would this be significant? If alpha were 0.05, this is smaller than alpha, isn't it?
Yeah.
Yes, so that would tell us to reject the null hypothesis. There would be evidence that the car repairs were higher.